Temporary Insanity, Video 2, Twin Strut Design. In this video we'll look at the concept and theory behind twin strut design. When I bought my Jeep I planned to add two things, lockers and a winch. Well, after having it over 10 years, I finally got a winch. But to have an ultimate off-road toy, you need rear steering and driver adjustable suspension. In this video we'll discuss the adjustable suspension. As I was researching my project, I found somebody as crazy as me in Pirate 4x4 forum. There was discussion in which somebody called IH Red Rider said he got some hydraulic rams from Northern. He put compressed air on top as a spring and hydraulic fluid on the bottom as a shock. Man, that sounded awesome. When compressed air enters the top of the cylinder, it pushes the piston down, lifts the vehicle, and expels oil to the tank. When air pressure is released, which lowers the vehicle, the piston goes up and draws oil from the tank into the cylinder. Whereas there are a few issues with that, the first one that comes to mind is stability. Consider if you had 3 inches of air in a cylinder. The cylinder could move 1.5 inches before the volume of air is compressed by half. Now if you have 18 inches of air in a cylinder, the cylinder would move 9 inches before the volume is compressed by the same amount. As I was driving along several years ago, I considered that if you hooked up dual-acting hydraulic cylinders with 2 hoses, you could push down on the piston rod of one, and the piston rod of the other will go up. And if you pull up on the piston rod, the second one will go down. Then I thought, what if we cross the lines? Now you push down on the first piston rod, and the other follows. You pull up, and the other follows. You hook something like this to the front axle of your vehicle, you have something like a sway bar, except without any give. So then I thought, why not add another cylinder? This time a double rod end cylinder, but put a spring on either end, preferably air springs. Thereby you can increase sway control by increasing the air pressure to the springs and increase flex by decreasing the air pressure. But wait, there's more. I could hook up a hydraulic system with a control valve to this sway system. Thereby I could force the suspension to lean one way or another. Hence you have the twin strut design with, of course, the auxiliary cylinders and airbags hidden in the trunk. One set of struts for sway control and the other for lift. However, coming up with all this, I noticed some design flaws. One of the less serious ones is the airlift struts. If I use 2-inch cylinders, the most a pair of struts will lift at 100 psi is 628 pounds, or 1,256 pounds for the whole car. The curb weight of a stock Tempo is over 2,500 pounds. I think they said they used 275 pounds on the Pirate 4x4 forum, so unless I find an air compressor system rated for over 200 pounds, I'll need another design. Of course I could run it hydraulically, but since oil does not compress, it would ride like a hay wagon. I could use accumulators like they use in lowriders, and I'm sure they'd be awesome on the street, but might provide a stiff ride on the trail. I found on eBay there are accumulators large enough for a comfortable ride on my vehicle off-road, but if I lower the suspension, it'll tend to bottom out. I need a stiffer ride when low and more travel when riding high. So I was thinking I could hook another cylinder in parallel with my lift cylinders and have it go to an airbag. That way I can lift the car with air or even hydraulically. I can even vary the stiffness by adjusting the volume of air in the bags. To save on parts, I could use 1 airbag per axle. After all, sway control I just described should keep me level. The other problem is a bit more serious. My sway control system as designed will not work. The upper chamber and lower chamber aren't the same volume, not even close. The area of the rod end equals the area of the bore minus the area of the rod. If I attempt to lower the vehicle, the sway system will try to force oil from the larger upper chambers into the smaller lower. Since oil does not compress, suspension would not move. So, I came up with a few alternative designs that might address the issue. First one I refer to as double bottom crossover. What if the rod end part of a cylinder was twice as small as the other end? I could use power lift gravity lower for the lift system, but instead of just plumbing the other end to the tank, I could plumb it in parallel with the rod end of the sway system. That would certainly solve the problem, except the rod on such a cylinder would have to be equal to the bore divided by the square root of 2. That would be a pretty odd number. Not sure if they even make such a cylinder. I haven't seen one, and I certainly don't have one in my inventory. The next idea I refer to as double rod end. Since both ends of a double rod end cylinder are both rod ends, both ends have the same exact area.
Therefore, using these, my system should work flawlessly, except that I'd have rod ends poking up through the body of my car as the suspension compressed. If you think a four-wheel drive tempo might look stupid, I'm sure it'd look even stupider with suspension parts poking up through the body as the suspension articulates. Of course, if I didn't have a body, that wouldn't be much of an issue. But what fun would that be? Even still, I don't have this type of cylinder in my inventory. But that does lead me to another idea. That being the crossover cylinder idea. Basically, the high volume of oil from the big end of the near cylinder enters the big end of the crossover cylinder. That forces a small volume of oil from the rod end of the crossover cylinder into the rod end of the far cylinder. The crossover cylinders can be hid under the body. This would certainly solve the problem, however at the cost of extra parts, weight, and expense.
But if the name of the game is saving parts and expense, why not do away with the crossover idea? Just have an independent cylinder and airbag on each corner of the car. I call this a no crossover idea. Of course, if I wanted to keep my dual strut design, I can plumb another cylinder in parallel on each corner. Suppose I could also scrap the hydraulic part and just use straight up airbags. But then again, I wouldn't have as much flex. And that would certainly save on parts, but wouldn't be as much fun, and as you can see, it's been tried before. Last but not least, I came up with the independent crossover idea. Remember how I said my crossover idea as originally designed would not work because fluids do not compress? Well, what if we got rid of the lift system and just used the original crossover, except with an airbag on each corner? Overall, I really like this idea and might go with this one. It's almost as simple as no crossover with some stability of crossover lines. However, one thing I don't like is you cannot control the amount of sway control. That is inherent to the dimensions of the strut cylinders. With a few ball valves, I could convert it from independent crossover to no crossover, but I can't really vary the amount of sway control. Of course, I might not need to, especially if I go with electronic suspension control. After all, you don't expect me to control the valves on various hydraulic and air systems all while trying to navigate my poor rig down the trail, do you? Electronic suspension control will be the subject for a future episode. Before I do that, I'll probably make a video on the steering system, and then I hope to do one on testing and implementation. So if you're still awake, do not forget to hit stop and rewind. See you next time.
To fight the unbeatable foe, to bear with unbearable sorrow.